2 months after a dramatic Christmas morning launch and several spine-tingling weeks of gyrations and unfolding, the James Webb Space Telescope has achieved what astronomers celebrate as first light. Designed by NASA, James Webb is on a mission to look further back in time by discovering stars and galaxies which are billions of years old, and ultimately revealing the logic behind the Big Bang. Scientists believe that if James Webb is successful, it will completely change the way we think and look at space. Hey everyone, welcome to Space Scientists. In today's video, we are going to talk about how James Webb Space Telescope will capture the first images of the Big Bang, and how it will help scientists understand the mystery behind the creation of the universe. So if you want to know more about it, then stay with us until the end of the video. And before we start the video, don't forget to like this video, subscribe to our channel, and ring the bell icon for more amazing videos. In partnership with the European Space Agency and the Canadian Space Agency, NASA launched Webb from Guyana on Christmas Eve last year, and right now, it's on its way to a point nearly 1 million miles away from the surface of Earth. However, the Webb's journey is not as smooth as it sounds, as it has to complete difficult mechanical tasks before actually exploring the universe. This telescope is so large that it had to be launched folded up inside another rocket, and over the course of several weeks, it needs to unfurl its various components, from its sun shield to its mirrors. According to NASA, a single point failure could potentially doom the mission. But when the telescope fully deploys in space, it will usher in a new age of astronomy and reveal dark secrets hidden deep in space which humanity has never seen before. According to a planetary scientist and astrophysicist at MIT, Sarah Seeger, the Webb represents the culmination of decades, if not centuries, of astronomy. We've been waiting for this a very long time. Researchers and scientists started thinking about a follow-up like James Webb even before the Hubble Space Telescope, which was launched in 1990, because after almost 3 decades in space, it has become unclear that how much longer this boundary-breaking satellite will be able to scan and photograph the universe. Therefore, the Webb telescope was brought to the development, which was originally supposed to launch in 2010 and cost around $1 billion. The long wait from 2010 to 2021 is a lot, but it will be worth it, at least according to the scientists who expect new and revealing glimpses of our universe. As Casey Caitlin, an assistant professor of astronomy at the University of Texas at Austin, has stated, "We're going right up to the edge of the observable universe with Webb, and yeah, we're excited to see what's there." The Webb is the answer to all of the unanswered questions about the universe, as it will explore what has not been explored until now. And according to scientists, the Webb will surpass the Hubble in several ways. It is believed that Webb will allow astronomers to look not only farther out in space, but also further back in time, as it will search for the first stars and galaxies of the universe. In addition, it will allow scientists to make careful studies of numerous exoplanets, planets that orbit stars other than our own sun, and even embark on a search for signs of life there. After a decade of delays and nail-biting weeks, the James Webb Space Telescope is deployed. Already halfway to its destination 1 million miles from Earth, it will now undergo a prolonged commissioning and testing, and that will involve first light images. Details are still emerging, but we now know that pretty soon Webb will be pointed at targets in the Large Magellanic Cloud, or LMC, a satellite galaxy of the Milky Way. However, that will happen only after its first blurry images are inspected during a long mirror alignment process. So, what exactly does first light mean? The phrase first light is used by astronomers when they begin observations on a new telescope, whether it's ground-based or like Webb, observing from space. However, first light can also refer to the possibility of imaging the cosmic dawn after the Big Bang. That's often associated with Webb because it will be used to image the very first stars and galaxies to about 300 million years after the Big Bang. According to Dr. John Mather, who is the senior project scientist for the James Webb Space Telescope, the Big Bang is a really misleading name for the expanding universe that we see. We see an infinite universe expanding into itself. The name Big Bang conveys the idea of a firecracker exploding at a time and place with a center. The universe does not have a center. The Big Bang happened everywhere at once and was a process happening in time, not a point in time. We know this because 1. We see galaxies rushing away from each other, not from a central point, and 2. We see the heat that was left over from early times, and that heat uniformly fills the universe. Then he was asked if James Webb Space Telescope will see back further than ever before, and in response to this, Mather said, JWST was designed not to see the beginnings of the universe, but to see a period of the universe's history that we have not seen yet before. Specifically, we want to see the first objects that formed as the universe cooled down after the Big Bang. That time period is perhaps hundreds of millions of years later than the one Cobb, WMAP, and Planck were built to see. We think that the tiny ripples of temperature they observed were the seeds that eventually grew into galaxies. We don't know exactly when the universe made the first stars and galaxies, or how for that matter. That is what we are building with JWST to help answer. NASA estimates that it could take up to 120 days after launch for Webb's mirror alignment work to be completed. Webb's very first test targets will be some stars that are the correct brightness that the team needs to help align the mirrors. Once the mirrors have been aligned, it's time to do something a lot more exciting, and that is to point Webb at its first non-star targets. Aside from its estimated 30 billion stars, the most famous target is the Tarantula Nebula. About 160,000 light-years distant from Earth, it's a famous target for astrophotography. Best thought of as a supermassive version of the Orion Nebula. It is 100 times larger and the biggest star-forming region in our part of the universe. According to NASA, it's so luminous that if it was close to us, as the Orion Nebula is, it would cast a shadow on Earth at night. Now coming to the question, how will the Webb outperform Hubble? The Webb has two major advantages over Hubble, and the first one is its size. However, it's not the size which is going to make the Webb extraordinary. When it comes to reflecting telescopes, the key component is the size of its curved mirror. The more light you can collect in this bucket, the fainter and farther away things you can see in the universe. Hubble's mirror was an impressive 7.8 feet in diameter, and comparatively, Webb's beautiful gold-hued mirrors combine for a diameter of 21.3 feet, which overall amounts to more than 6 times the light collecting area. And this was it for today. What are your thoughts on today's video? Share your views with us in the comments below. Also, don't forget to give this video a thumbs up, subscribe to the channel, and ring the bell icon for more amazing videos about space. And thank you for watching.